Let's break down what machine learning is for those who might not be familiar with. Machine learning is like a special part of artificial intelligence where we teach a computer to learn things all by itself from the experience, without giving it a strict set of instructions. It's really cool field with a lot of practical uses in various areas. Now, if you want to become really good at machine learning, you gotta work on a bunch of different projects. In this video, I'm going to guide you through building a machine learning model step by step. So we'll cover these important topics. Oh, and before we dive in, if you could hit that subscribe button, it would be really awesome, and I'm also super excited to share that I'm working on something big for this channel. I'm going to create a whole course on machine learning with Python, so make sure to stay tuned for the updates. So now let's get started. So first, let's load the data. The dataset we are working with is all about charges from patients. I strongly suggest you to grab this dataset and code along with me. You can find the dataset in the link I have provided. First things first, we need to bring in the dataset. I'm going to do that using a library called pandas. Think of pandas as a super helpful tool for bringing in and getting data ready for the analysis. So let's start by importing pandas. Now with pandas at our disposal, I'm going to load up our dataset using an handy method called read CSV. It's like opening a book and getting ready to read it. Now let's peek at the beginning of our dataset. We can do this using head method. It's like flipping through the first few pages of our data book. Take a look. We have got 7 columns here, which is age, sex, body, mass index, number of children, smoking, region, and charges. Each column holds some important information about the patients and the charges they have incurred. And if you ever find yourself stuck on something or need more information about this video, don't hesitate to visit the blog. I have got a lot of helpful stuff there. Also, there's a special discount waiting for you if you want to go to the premium. Just click on the link below to claim it right now. Now, let's keep the ball rolling and move on to the next part, which is understanding the dataset. Before we dive into building our machine learning model, it's super important to get to know our data really well. It's like getting to know the characters in a story before writing a book. Let's start by finding out some basics about our dataset. First, we need to know how big our dataset is. That means how many rows, kind of like entries and columns. Think of them as categories or characteristics we have. To do that, I'm going to use the shape thing, which is like asking how many pages and chapters our book has. And there you have it. Our dataset has 1338 rows and 7 columns. It's not too thick of a book, but it's got enough to tell us some interesting stories. Now, let's dig a little deeper. We want to make sure our data is clean and doesn't have any missing parts. To check that, we use the info method, which is like looking at the table of our contents of our book. It tells us a lot about what's inside. Great news, no missing data here. You can also use the is null thing to hunt for missing data, but trust me, we won't find any. Just to double check, I'm going to use something which is like counting the numbers of missing pages in our book. As you can see, no missing data at all. Our book is complete. Now, something else is important in knowing the types of information in our column. It's like knowing if the characters in our stories are heroes, villains, or something else. To do that, I'll use a D-type thing, which is like checking the character list of our books. And there you go. Now we know what kind of characters, data types we have in our dataset. Now let's keep the momentum going and move on to the next part, which is data processing. Now we are going to make sure our data is all set and ready for our machine learning adventure. First, let's make sure our data is in the right format. We'll convert those columns that are like text into a special category format. Now let's check the types again just to be sure everything is in order. Next, we want to understand our numeric data better. We'll use the describe method to get the scope on the things like the average, minimum, and maximum values. If we flip our data around transposing it, it's like looking at the stats more neatly. Now let's see how much money smokers and non-smokers tend to spend. To do this, we'll group our data with the group by method, and I'm going to round the numbers to make them easier to read. As you can see, smokers tend to pay more than non-smokers. It's an interesting tidbit from our data. Now it's time to visualize our data. Data visualization is like creating a picture book to help us understand our data even better. To do this, we'll use a cool library called Seaborn, which works with another one called Matplotlib. It's like having special tools for drawing graphs and charts. First, let's bring Seaborn into the picture. Then, we'll choose a style for our plots. Now, I'm going to use the pair plot method to show the relationship between our numeric variables. It's like drawing connections between different ingredients. For example, we see that as age goes up, both smokers and non-smokers tend to pay more. Next, Let's check out the correlation between our variables. It's like figuring out which ingredients go really well together. Notice that there is a relationship between charges and other variables. It's an important clue for building our machine learning model. Now, we're going to make sure our categorical data, which is the non-numeric stuff, is ready for our model. We'll use a trick called one-hot encoding with pandas. It's like turning our categories into numbers that our models can understand. And just like that, our categorical data is now in the format that our models can work with. We have created a new column for each category, thanks to pandas, and it's a breeze. So our data is all set and ready for building our model. Let's dive into the exciting part, building a regression model. When we build a model, we start simple and then get more complex if needed. In this case, we are going to start with a linear regression model because we are predicting a number, which is the charges. But before we can build a model, we need to know what we are predicting. I mean the charges and what we are using to make that prediction, which is the other data. So let's assign our target variable, which is charges, to a variable called y. So now we are going to build the model. Now that we have got a model all set up, it's time to see how well things are doing. It's like checking the score of your favorite sports team after a game. But before we do that, let's remember that our dataset has two parts, the target variable and the features. Now, to make sure our model is really good, we need to test it on the data it hasn't been seen before. It's like seeing if a recipe works with ingredients we haven't used before. We do this by splitting our dataset into two parts, one for training the model and another one for testing it. We can easily split our data into 80% for training and 20% for testing using a helpful method called scikit-learn. Think of it like dividing your ingredients into two sets of cooking. Now, it's time to build your model. To do that, we need to import a special tool called linear regression from scikit-learn, and then we need to create an instance of it. And now our model is ready to go, and we just use the training data to build it. And the most final part is we need to evaluate this model. Now let's see how well our model performed. To do this, we used something called coefficient of determination. The closer this value to 1, the better our model is at making predictions. First, we check the score of a model on the test data. It's like checking how many points our team scored in the game. In our case, the coefficient of determination on the test data is greater than 0.7, which means our model is doing a decent job. Of course, it would have been even better if it's closer to 1. Now, let's look at the score of the model on the training data. You'll notice that the performance of the model on the training data is similar to the test data. If it was too high on the training data, it could mean that our model is trying too hard and fitting too closely to the data, which is not good. It's like a player who practices so much that they only perform well during practices but not in the actual game. To avoid this problem, we can use something called regularization, which is like setting up some rules for our model. We can use models like reg or lasso for this. Now we're going to use another metric called mean squared error to evaluate our model. First, we predict the test data with our model and then we calculate this metric. To do that, we import a special tool and use it. And there you have it. The square root of mean squared error tells us that our model predicts with a standard derivation of 5956.45. It's like saying a recipe can sometime vary by this much. Now it's time to move to the final part, which is the model prediction. Now let's put a model to the test and see how well it predicts. To do that, I'm going to predict the outcome for the first row of our training data. It's like guessing the taste of a single bite of our meal. So I'll pick the first row and use a model to predict what it should be. Now let's see what the real value is. And look at that. Our model predicted something pretty close to the real value. I have shown you how we can use a real-world dataset to build a machine learning model using Python libraries. It's not as tough as it might seem, and Python makes it really accessible. That's all for today. I hope you find this journey enjoyable and informative. If you like this video, just consider subscribing to my channel. We got more exciting stuff coming up. Well, that's pretty much it. I'll catch you guys in the next video. Peace.